Next topic is diffraction of light. What do you mean by diffraction? When the obstacle is there in the path of light get deviated from, it will get bends along the obstacle. Like if this is a slit, light is going straight, light will circle around the obstacle. It will bends around the obstacle. This bending of the light around the obstacle, that is called diffraction of light. So, in the diffraction of light, it's a phenomena occur when a wave encounter an obstacle or a slit. It defined as the bending of light around the corner of an obstacle or aperture in the region of geometrical shadow. That is called diffraction. And different diffraction patterns are obtained on the screen due to the light. There is an experiment of single slit diffraction. For the single slit diffraction, what we have, say this is a slit, a lens is there to focus it on the various points. If the light, say from here, it will focus it on the center. So at center, maxima will be formed. Now for the first secondary minima, we consider slit to be as 2 points. That light reaching from here, and this is the other part. So here the phase difference is of lambda by 2, and this also offer a phase difference of lambda by 2, and net phase difference that will lapse to lambda. So this both waves are out of phase and will form minima or the destructive interference. For the third, that is again a maxima, now let us consider the slit to be in 3 parts: 1 part, 2 part and 3 part. Again the lens and the screen. So 1 part, 2 and 3. So it will offer a wavelength of lambda by 2 and lambda by 2, and there is net wavelength is of 3 lambda by 2. So this time it is not out of phase. It's again having a difference of 3 lambda by 2, and it will form a maxima here. So according to the Bragg's condition, ND 2d sin theta equals to n lambda, 2d sin theta equals to n lambda. This is the condition. This time this is the condition for the minima. So in the case of interference, the condition we get for the maxima is actually a condition for minima in diffraction and vice versa. So for the diffraction, one more point is there. For the diffraction, central maxima has the maximum intensity, and then as we move further, intensities keep on decreasing. This is the central maxima. This is the secondary minima. This is also the secondary maximas. So we can observe that their intensity keeps on decreasing. So this type of diffraction pattern we get for So this was about the diffraction of light.